All right. Section 8.3 is all about multiplying binomials together. So I'm splitting this into a two-part video. The first part will go pretty quickly, but it's all so the previous video 822 talked about factoring, and before that we talked about distributing, and we're going to kind of compare those first, and then we'll get into the new content. So our topic is multiplying binomials. EQ is how can I multiply two binomials together? And then our warm-up is to find and factor out the GCF from each expression. Okay, so I'm going to start with this trinomial. There's three terms. I see coefficients of 3, 15, and 18. So I can divide all those by 3. Because the first number is positive, that means I'm going to go ahead and just take out positive 3. They do all have the same variable x, so x is going to be part of my GCF. But since this 18 only has one power of x, that means just x to the first is going to be my greatest common factor. And again, you don't need that 1 there. So now the idea with filling in the parentheses is what's remaining in this term if I divide by 3 and I take a single x away. Well, 3 divided by 3 is 1. I had x to the third, but I took one of them out, so now it's x to the second. Okay. If I move on to the second term, negative 15 divided by 3 is going to give me negative 5. There was x to the second power, but now that's reduced to x to the first. And then finally, 18 divided by 3 is 6. There was a single x there before, but I took it out as part of the GCF, so that is done. This is my factored answer. Every one that you see in here is unnecessary. You do not have to write it, okay? So there's that. And then here, now this is the first example we've had where there's terms with multiple variables in it. So again, just to kind of reiterate a term, there are 3 terms there. They all have a number. They all have variables. So what number can divide negative 6, positive 10, and negative 2? Well, 2 can divide all the numbers, but I want to take out negative 2 as part of my GCF. Now, what else do all 3 of those have in common? Do they all have the variable x, or do they all have the variable y, or do they all have both? And the answer is all 3 terms have the variable y. They do not all 3 have the variable x, so I cannot take x out as part of my GCF. Okay, so negative 2, I'm dividing by negative 2 and taking a y from each term. So negative 6 divided by negative 2 is 3. The x squared stays unchanged, and that y is now there as part of the greatest common factor. So if I move to the next term, 10 divided by negative 2 is negative 5. The x stays, and the y is now gone. Again, it's right there. And then finally, negative 2 divided by negative 2 is positive 1. There's no x. The y is gone, so it's just plus 1. So this is our factored answer. Okay. All right. So kind of a quick little recap from 822. Not going to spend a whole lot of time on the slide, but if you want, this is a good one to kind of pause the video and a good thing for your notes, just to kind of separate and discuss the difference between and the similarities really of multiplying or distributing versus factoring. So multiplying is distribution, factoring, find a GCF is doing the opposite. So they're related, but they truly are opposite processes. Okay. If you want, go ahead and pause to give a try on these factoring problems. I'm going to just jump right in. I have 3 terms. The final term does not have x, so x is not going to be part of my GCF. So all I can take out here is 9. 9 goes into both, or all 3, 18, 9, and 27. So 2x squared. The nice thing about only taking out a number is that I know that my variables are going to stay unchanged. Those powers will stay unchanged. Okay. And then over here, 15x to the third plus 25x squared minus 5x. I recognize the coefficients can all be divided by 5. They do all have x, so x to the first power I can take. from every term. This becomes 3x to the second plus 5x to the first, and then just minus 1. Now, I keep saying that the ones are unnecessary. These ones are unnecessary. You have to put this minus 1, though, at the end. If the only thing left in a term when you take out the GCF is 1, you have to put something there. You can't just leave a blank space. You do need to fill it with at least a number, and in this case, 1 will do the trick. So to get into the bulk of what we want to talk about in the rest of this lesson is how do I multiply binomials? So everything we did in 8.2 was a single term and then distributed through a set of parentheses. Well, what if this is already a set of parentheses multiplied with another set of parentheses? And really all it comes down to is we're going to do 2 rounds of distribution. Okay, so I'm going to take each of these terms individually and distribute each of those 2 terms to the other set of parentheses or the other binomial. Okay, so I'm going to start with 3x, and I'm going to distribute that to both of those terms on the other side. If I do that, 3x times 2x will give me 6x to the second. 3x times negative 4, well, 3 times negative 4 is minus 12, and then I have an x there. Okay. Now I'm going to switch colors because I'm going to distribute again, but I'm going to go ahead and distribute a 1. Now, what's kind of nice about distributing the number 1 is anytime you multiply something by 1, it stays the same. So I'll have just 2x and minus 4. Now, here's where we get to do a little bit more work than we did prior. And if you think about 2 terms times 2 terms, well, 2 times 2 is 4. And so sure enough, I have 4 terms here. But can I combine any of the 4 terms together? 6x to the second, that's the only x squared I see. Minus 12x and plus 2x is going to be minus 10x. And then finally, to wrap this up, minus 4 is all by itself. So minus 4 is just comes down. And so this right here is my final simplified expression. Okay, so when I'm multiplying binomials, it's basically just 2 rounds of distribution. You may have heard of the phrase FOIL before, or the acronym FOIL. I don't love it. It's just basically reminding you to multiply everything in the first binomial with everything in the second binomial. Another way you can do this that I really like is what I call the box method. And it's really just breaking down each set of parentheses so you don't forget to multiply something. So what I'm going to do is I'm going to take this first binomial, 4x squared plus 2, right? And I call it a binomial because there's 2 terms there, right? 4x squared is the first term and positive 2 is the second term. So I'm going to go ahead and just write those terms on the outside of one side of this box. Okay, so 4x squared and plus 2 are my 2 terms. And then over here, I'm going to do 3x in my other. So my other binomial is going to go up top of the box, again on the outside. So 3x squared, and then the second term is plus 5. So that goes on the other side. Now what I'm going to do is I'm going to fill each box in by multiplying what's to the left of it and then what's above it. So to fill in box number 1, right here, the upper left-hand box, 3 times 4 is 12. X squared times x squared is x to the 4th, okay? And then to fill the upper right-hand box, I'm doing 4x to the second times positive 5. Well, 4 times 5 is 20, and that x squared stays the same. Lower left are those 2 terms, so 2 times 3x squared is going to be positive 6x squared. And in the lower right-hand corner, I have positive 2 times positive 5, which is positive 10. Okay, now, the boxes are filled up. So what that means is, and you could have just distributed this, what that means is my 4 terms are 12x to the 4th plus 20x squared plus 6x squared plus 10. Okay, the order doesn't matter. If you put plus 6x squared and then put plus 20, that's fine. And then to finish this, I just want to make sure, can I combine any terms? And just like the previous problem, I see that in the middle I have 20x squared and another 6x squared. So that's going to become plus 26x to the second. Remember, when you're combining like terms, you are not changing powers. Okay. Back here to fill out the box, we multiplied x squared and x squared to get x to the fourth. That changes powers. But when you're talking about when you're talking about combining like terms, you are just combining the coefficients. So 20 plus 6 is 26, but I am not changing that exponent. So 12x to the fourth comes down, and plus 10. And then this is my expression. That's my answer, so to speak. Okay, so whether box method, distribution, whatever you want to do, doesn't really matter. But go ahead and pause right now and give one of the methods a shot. The box is there just in case you want to use that. Okay, so negative 2x squared plus 1 is my first binomial. And then the second binomial is 5x minus 3. Okay. So I'm going to go ahead and fill out the boxes by multiplying. So this would be negative 10x to the third, because I have two x's with one x. Okay. Upper right, I got positive 6x squared. Lower left, I have positive 5x. And lower right, 1 times negative 3 is negative 3. Okay. So I have these four terms. Negative 10x to the third plus 6x to the second plus 5x minus 3. And what I see in this particular problem is all four of these terms have different exponents. So there's nothing I can't do any combining like terms, and so I'm done, which is kind of nice. Finally, we're going to talk about how do I multiply a binomial with a trinomial. It's actually the same idea, it's just two more terms that I'll have in my final answer. And so you'll notice if you want to do the box method, just draw a box that matches how many terms are in each set of parentheses. So x minus 4 are only two terms. And again, if you want to put a 1 there, you can. And then my second set of parentheses is a trinomial. So I have to break this up into 3 minus 8. Okay. So here I've got, if I'm multiplying, this is 3x to the third. This is 1x squared. That's minus 8x. In the bottom row, I'm multiplying everything by negative 4. So negative 12x squared minus 4x and plus 32. Okay. So instead of writing all 6 of those out, I'm going to go ahead and see if I can combine any of these right now. This 3x to the third, there are no other x to the thirds, so that's by itself. I do have 1x squared and negative 12x squared, so it's going to make minus 11x squared when I combine those terms together. Then I have minus 8x and minus 4x. Negative 8 and negative 4 is minus 12. And finally, I have plus 32, which is the only constant or plain number. So this then is my simplified formula, expression. Again, there's no equal sign, so that's why I keep using the word expression. So 6 terms to start, but my final answer only had 4. Still a polynomial, but not as many terms as we started with. So how can I multiply 2 binomials together? Really, it's just 2 rounds of distribution. And then don't forget to combine like terms. Check to see if we can combine like terms. Okay, that'll do it for video 1 of 8.3, and then we'll wrap up 8.3 and the first half of chapter 8 on the next video.